XML. Yeah, so we'd like to be able to share data with others that don't necessarily have a direct access to our enterprise data, right? We'd like to make it available. Folks, companies started to realize that they had collected quite a bit of really valuable information throughout their years as a business that was just sitting there and that only had value to them as part of the enterprise, right? But they saw that there was a lot of potential on having that data if it were shared with other folks, integrated and meshed with other or aggregated with many other businesses. That there could be a lot of value with this data, right? So they were looking for mechanisms to share, right? To make this available for others, perhaps at an API that could be easily accessible through network, right? So like I mentioned earlier, right? There might be several businesses that would like to integrate, perhaps because they have mutual interest, or even because of part of an acquisition. Imagine most businesses have grown because they've acquired similar either competitors or smaller operators. Imagine Hertz, right, as a rental car. They have been slowly perhaps purchasing other folks that might be local, smaller companies that do car rental, but how do you integrate them, right? Because they might have their own databases, they might have their own storage of how do they represent customers and clients and their cars, and they all need to be integrated, right, and represent in one single normalized representation of the data model, right? Even banks, when they acquire each other, same thing, right? Or telephone operators, right? Or mobile phone operators. Then they might acquire the competition, or they might merge together, and their databases completely have different schemas, but they have to come and migrate and integrate and merge into the single representation. So next time I used to call and ask about certain questions to my bank or my mobile operator, and sometimes they couldn't find me. It says, oh no, yeah, you used to be at Sprint, or used to be at whatever, right? But we purchased them. You haven't yet been converted, and now I understand the challenges of migrating data from one to another. It's very, very challenging. So we need to be able to represent them. Users might not have direct access to the SQL. They might not be able to just sit in the command line and just type SQL commands, right? Or they might not have access to the JDBC or even the application layer, the data layer that accesses it. So we need to look for some other mechanism that we can serialize, right? Somehow represent this in a non-proprietary mechanism, right? That can be shared with others. It could be the actual format is somewhat arbitrary, right? On what is it that we choose how we choose it to represent it. It could be some comma separated values, right, in a CSV file, or it could be represented by different tabs, right? And that's how we represent the different columns. It's fairly arbitrary how we choose to. Typically, what we like to be able to do is to have the same expressive power that some of our newer technologies allow us to have, right? Like, for instance, object-oriented technologies allow us to represent it in a very hierarchical fashion, right? Where you might have smaller components be part of or representing things that are bigger, right? And so smaller modules can build on top, can be used to build something bigger and something bigger and something bigger. Then we create those layers of abstraction. It'd be great if whatever format we choose, right, would allow us to interpret data again at that kind of hierarchy, right? Where you can think small, but you can also think big, right? At different layers of abstraction. Okay, so XML was a language that allowed us to do that, right? It provided the ways to represent things hierarchically, right? Where you can nest data inside of other pieces of data. It allowed you to annotate it to give it some context or some meta information about the data, right? Whether the data type, this was an integer, this was a string, this was a right. That you can create these data representations that you can provide different ways to annotate either with attributes or as part of elements. And you can basically also create a schema where that those documents could be validated against, right? That you can describe the structure of a valid XML document, right? That you can then run a validator and validate and see that that document actually matches that particular schema. So it afforded all the great things that that object orientation and other hierarchical data representations afforded us, right? Strong typing, hierarchy, different layers of abstraction, right? Validation, schemas, right? All these things were there, and also just be easy to be serialized and transferred across a network in just plain ASCII, and stored in an ASCII file that any human could open up and just read, right? It had no proprietary binary representation, right? That nobody could understand, right? It could be just plain old ASCII text, okay? Not that it was meant to be consumed by a human being, but a human being could open it up and just with a regular text editor just make minor changes, right? And make some changes. So it had a lot of things going for it. Okay? Certainly the closest perhaps that we've the most familiar use of XML that all of us might be familiar with is the use of HTML, right? HTML is just one of an infinite number of vocabularies with XML, right? XML was meant for being able to extend, right? Extend and create your own languages, right? And a language is basically just a set of vocabularies, right? And rules and syntactic rules on how do you define things, right? And HTML is just that. It's XML, right? It's using XML to declare a proprietary, a specific language for use in display in the browser, right? Where you create the vocabulary such as tables and labels and input fields and buttons and whatnot, right? And that same things can be nested in only one particular way. Right, so that's HTML. That's one of the more common and more famous uses of XML. Right, but there's certainly a plethora of uses of XML for describing any type of data. Right, and we can certainly use it for our own purposes. Here is our own proprietary representation of being able to represent various courses, right, and folks that are enrolled in different courses. We have elements that represent the enrollments here. You have an opening element and a closing element, and then you might have several instances of different courses that were taken, right? And in this particular representation, we are representing each student in multiple times, represented here in multiple instances of course taken, right? And where we display we're capturing the name of the user, the graduation year, the title of the course, and the year that was taking, and the grade they received in that course. Right? Notice that we have 3 entries for Ian. Thank you. That Ian took several courses: calculus, Shakespeare, and pop culture, whereas Ben took 3 other courses: Shakespeare, databases, and calculus. Right? At different years. They got different grades and whatnot, right? So whoever wrote this chose to represent that data using attributes, right? These are attributes and with name-value pairs. They could have chosen a different way to represent it, right? Where instead of using attributes, they could have used dedicated elements, right? Elements to represent the names, elements for the graduation year, elements for the title and whatnot, right? They're considered to be completely equivalent to each other, whether you choose to be an attribute or whether you choose to be an element. They're equivalent, only with the caveat that obviously if the data that you're storing is fairly large, right, a more convenient representation is to use an embedded element with that particular name. So yeah, so here in this case we have enrollments being the root element, right? You have a root element that kind of encapsulates the entire data that is being stored there, and then you have several child elements embedded inside of the root element, course taken, one per course in this case, right? We often refer to these elements as tags, right? And if the tag notice that this tag over here, or element, enrollments, has an opening element, and then you have a closing tag over here, right? And then you have what's in between the opening and closing, we refer to as the body of the element, right? So you have the opening tag, closing tag, and the body that is contained inside. Yes? If the element has no body, then it's optional. You can just close it, self-close it by putting a slash at the end. Right? Notice that the difference between the opening and closing is that they have the same name, but you have a slash. We also say that the tag has a name. All right, so the name of this one is the enrollments. That's the name of that tag, course taken and whatnot. Everybody okay? Right. You should find this very familiar already. You have brackets, attributes, and have the semantics on how they're building. Okay. We also say that course takens, all these are siblings to each other, right? They are all at the same level of the tree, hierarchical tree, right? We say that the root is the enrollments, and then you have multiple branches coming off of it, right? Where you have multiple course takens, right? Course taken instances off of the same root, right? So course taken elements are all siblings to each other. They're all the same layer, right? They're only one level down. Now we might decide that if we have certain year or certain data that is redundant, right? That we would like to abstract, and perhaps instead of having that kind of redundancy, it could be represented at the parent level, right? So for instance, if we have here that all these folks, they all graduated the same year, right? In this case, let's see, in the original one, notice that they all graduated in 2009. See that? Okay, so if that's the data that's being abstracted, and that's how we could decide that we can roll all that up into the parent, right? Instead of just redundantly capturing over and over in the siblings, yes? Or we might decide to implement this in a much more hierarchical way, right? Where we can nest the data, right? So for instance, in this case, we have the graduating students. We have perhaps several instances of these students, right? You have, here's one student, and then there would be another instance of another student following, being a sibling of this one student. Here we have Ian, again, grad year, and the courses that were taken. See that? So this is a presumably an equivalent representation of what we saw earlier, right? But grouped by student, right? As opposed to instead of capturing the student multiple times, right? One entry per student. Instead, we decided to have it in a more normalized implementation, right? We have the same issues here of normalization that we have in the schema when we talk about relational databases, right? Of redundancy and whatnot. Same concerns apply, right? Same concerns apply here. We have the issue that the name of the student is repeatedly represented here, right? Name, Ian, Ben, right? Right, and you run the same risks of that redundancy gives you, right? Of inconsistency, right? If I inadvertently change one of these records but don't change the other ones, then I would run the risk of inconsistency. Imagine that I changed. Notice the graduation year is being captured 3 times over here for presumably the same user, Ian, right? What if I somehow inadvertently change this one element and I make a mistake and change it to 2010, but don't update the other ones, right? That would introduce inconsistency in the data. So the same things apply here, right? We're still trying to eliminate or reduce or avoid the use of redundancy. So we might choose a more normalized representation where we have here students represented only once, and here's the name, the graduation year, again, only once, and then the courses. But then you might run into the issue of saying, well, what about if somebody else took calculus? It's being represented here for Ian, but then it's going to be represented again for Ben, right? So now you have the same issue, but for the courses. Before it was for the student, and now it's for the courses, right? So you would use other ideas like we've considered in when we normalized relational databases of using references, right? Where instead of embedding courses as part of the student, perhaps we have a section that captures only students and another section that only captures courses, right? And where the list of courses for the student only reference the ID of the course that is then represented elsewhere, okay? Again, it depends on the use case, right? How is it that you're going to be using this? And it's going to come up a little later when we talk about JSON. We're going to have exactly the same issue, right? Of how to normalize it, how do we remove redundancy, how do we remove inconsistency, right? So anyway, so this person decided to include all the courses represented embedded inside of the student, right? So in this particular case, this would be represented as follows, where we would have a root graduating students, and then you have the various siblings of students in the second layer, and then in there you would have a child course list that would have several siblings representing the courses inside of the course list for that particular student. All right. Again, the same issue here, that calculus is represented once here, title and year taken, and the title over here. The title is being represented twice, whereas the year taken, perhaps they don't necessarily have to be the same, right? I might have taken in 1 year, you might have taken in a completely different year. We might have gotten different grades, certainly. And this title, maybe a better representation would have been to have this be an ID, right? The ID of the course that is can then be joined, right, with other records represented elsewhere, right? Instead of just the title, right? Because if I change the title of the course, right, then I would need to make sure that I change it everywhere here, right? It would have been better to represent it only once. Anyway, so there's a XML. And so one of the things that would like to be able to learn how to do is, how do I, write XML, parse XML, represented in a Java data model, and how we represent it in a database model. How do we do the mapping between the two? How do we transform this? For instance, one of the questions that often comes up is, here you have a very flat representation, whereas over here you have a very normalized representation, and it could be that one of the businesses, right, wants it in a flat representation, and some others might want it in a more normalized representation, right? Because it depends, right? Because depending on your business, you might be interested in different layers of abstraction, right? For a Ford Motor Company, maybe they would like to have a very normalized representation of a car. Right, they want to know every detail that you want to know about a car, about the doors and the knobs and the switches and the leather and the seats and the recliners and all the springs and all the nuts and bolts. Right, want to make sure that they have and are storing this and keeping track of all this. Right, and perhaps they use a very normalized representation for in their database. But us at the university, we also want to maybe have a representation of a car. Yes, but maybe for us, the representation of a car is enough to know the license plate, maybe the color, the make, and the year. That's it, right? So depending on on your particular business, right? My representation of one object might be different from your representation of the same object. Yes. And if we want to interact, right? If we need to interact somehow, we need to come up with an intermediate representation that might work for both of us, but I'll then need to convert it back into my own data model, and you'll need to convert it back into your own data model, right? As long as we agree on what the contract is in between. That make sense? Right. So I like to explore a little bit of that conversion between the different data models that we can use from XML. Right. So first, let's look at this very low level manipulation of XML from Java, right? This representation is more or less what we explored earlier when we were looking at JDBC, right? When we were doing very low level select statements and inserts and updates and whatnot, right? Where we iterated over all the columns and the rows and whatnot. That's very low level, right? We then decided to, okay, that's fine. I know I can do that, but I'd rather provide a higher level representation, right, where I can talk about objects instead of talking about columns and fields and whatnot. Yes. So first, let's look at this low level manipulation of XML first, right, and then we'll explore a much higher level interaction that we can have with XML schemas. Okay, let's look at XML, DOM, and Java.